Hello, Algebra Scholars, and welcome back. Happy Wednesday. Again, sorry I can't be there, but I'm here. So thank you for being here and putting in 100% effort. Today we are going to have our first algebra lesson, so let's see how this goes. Okay, what I'd like you to actually do is on the honor system here. I'd like you to pause the video and try the warm up. So go ahead and multiply 6 times 19 and 3 times 132. This would be the part where you pause the video. Don't cheat. Pause the video. Your partner's going to rat you out. Pause the video. Okay, by now, you should have paused the video. And I'm curious, in person, I would be able to see how you chose to multiply both problems 1 and 2. And we're apart, so I can't quite see. But I'm wondering if you, by any chance, tried the area model. By no means was it mandatory, but it's something that you may want to consider because it has absolutely everything to do with today's lesson on distributive property. Okay, so you are allowed to multiply by using the area model. So I have a 1-digit by 2-digit number. So the 19 I like to decompose in a friendly way, so I can call this 10. It's wider, and 9. And I'll get this one set up while we're here. I could call this 3. And again, if I decompose 132, I could call this 100. Line this up. And we have 30 and 2. I'll go back and fix that in just a bit. Hopefully my Wi-Fi is going to stay with me here. Come on. And a 2. Okay, so inside the box, we find the area here. So 6 times 10 is 60. Okay, and we have 6 times 9, which is 54. And I'm having some fun technical issues here. By now, you've probably simplified this expression about 50 times. Okay, so if you multiply, we have these partial products here, and then you can go ahead and combine them. In total, you get 114. Okay, so I'm curious how many of you actually did that using the area model and how many of you did that traditional multiplication algorithm. There's nothing wrong with either method. It's just I wanted you to try something different. Okay, same thing here. We can multiply, find the partial products. So we'd get 300. I'm about to abort mission on this one. 300. 3 sets of 30 would be, you guessed it, 90. And then 3 sets of 2 would be 6. So some people like this way of multiplying because it's a lot easier to do if I were to ask you to do this in your head. Okay, if we bring together those partial products, 396. 396. This is a very friendly way to multiply. So if you're having a hard time today with our distributive property method, I want you to visualize an area model, and that'll really help you keep track of what to multiply. Okay, so I'm going to go ahead and go in presentation mode, and let's do this. Again, feel free to stop the video at any point. This is going to be a little bit of a longer video because I need to spiral in some 7th grade reminders. Okay, so here we go. Our objective today is we are now going to be working a little bit of 8th grade, a little bit of 9th grade standards here, but you're applying knowledge of distributive property to simplify algebraic expressions. Sounds challenging. Let's give it a go. Okay, by now we should be done with our warm-up. You were honest and you multiplied. And now we're going to go ahead and get into our lesson here. Okay, so recall from the previous lesson we talked about there's a bunch of different ways to represent multiplication because mathematicians, we like to make your job harder and more difficult and confusing. So we throw lots of symbols that mean the same thing at you. Okay, so just keep in mind all of these imply multiplication. Okay, so we're going to go just take a field trip back to 7th grade for a moment. Some quick vocabulary. So when I say the word expression, this refers to anything that has numbers and symbols and operations, and they may be grouped together and they show the value of something, okay? It does not have an equal sign. That's an equation, okay? So we're not solving today, we're just simplifying. That's the main takeaway, okay? No equals today. Okay, Also, each of these little nuggets of math, as I call them, they're referred to as terms. So they're different parts of expressions, and they can be separated by an addition symbol or a subtraction symbol. Remember, the sign remains attached to the term, so the following term. Okay, so that is a -9 at the end and a positive 5y in the middle. Okay, variables are friends. These are letters or symbols that we use to represent a value that we just don't know the value of. Okay, and again, we're not solving today. Coefficient, when you hear me say the word coefficient, this refers to the number in front of the variable. Okay, when they're touching, like the 3 is touching the x here in the picture, it's implied multiplication. This is 3 sets of x, 3 times x, and 5 sets of y, or 5 times y. Okay, so those coefficients are together through multiplication. And the constant. That's just a fancy way of saying the number. It's a fixed value. So for instance, the only constant that is pictured here is the number -9. Okay, these are not constants because they're attached to variables. Fun times. Okay, now like terms. So like terms are exactly what they sound like. They are terms that are alike. Okay, they have to have the same variable. They have to have the same exponent or raised to the same power. And the order of them does not matter. Okay, and constants are like terms. Okay, so any constants, any numbers you see, we can bring them together. They are alike. They are like. Okay, so characteristics. The coefficients do not have to be the same. If variables are multiplied, the order listed doesn't matter. And we can combine like terms by adding or subtracting the coefficients. Okay, so here are some examples of like terms. 3x and 4x. They have the same variable, the raised to the same power, which is 1. 5 and 11, they're constants. They're like terms. I can bring them together. I can add them together. If you had a term like xyz and xyz, you could add those together. 4x squared and 7x squared, notice how they have the same variable, and that variable is raised to the same power, in this case squared, or to the power of 2. They are like terms. In the bottom right-hand corner, these are terms that are not alike, and we cannot add them together. Okay, so all of those in the corner. Okay, it's important to note here, like for the red one, the reason why we can't bring these two together here is because the power of 2 is attached to the x, and this x only has a power of 1, and vice versa for the y. They're not the same. They're not raised to the same power, so we cannot bring them together. Okay, here we go. I think this is our last vocabulary word. Okay, so distributive property. Whew, get ready for this. When multiplying a sum or difference of terms, you can multiply each term inside the parentheses separately. Okay. So this is an example where the definition is much more complicated than actually using the distributive property, so don't get intimidated. Okay, this was actually one of the easiest definitions I could find. Okay, it's really not as bad as it looks. So let me show you via algebra tiles what the distributive property really looks like. Okay, suppose you have an expression 2 times the quantity of x plus 4. That's just saying you have 2 groups of x plus 4. So I have my algebra tiles here that you guys love so much. X plus 4 ones, and I made 2 groups of them. If I were to combine those like terms, those like tiles, I could take my 2 x's and add them together, and my 2 sets of 4 and bring them together to get a simplified expression. I use the distributive property. That's all it is. I'm distributing in that 2 to each term. Okay, same thing here. If I want 3 sets of the quantity of 2x minus 5, I could model that using algebra tiles, bring together my like terms. I have a total of 6 x's and 15 negatives. So either of those expressions I could use to represent. And here's one more. 2 sets of the quantity of negative 2x plus 3. Again, I'm going to gather those like terms. I have 4 negative x's and 3 positive 1's. And last, 5 sets of the quantity of negative x minus 2. is the same thing as having 5 negative x's and 10 negative ones. Okay. My seventh graders did not like the algebra tiles last year. You remember that? You remember that? Yeah. They didn't like it very much. Okay. So there's an easier way. If you haven't caught on by now, we'll pull those algebra tiles away. Hopefully you discovered that by now you can just simply multiply in that number or multiply in that multiplier. So 2 here is going to be multiplied by x and 2 would be multiplied by 4. So that multiplier has to be multiplied in by each term. Okay. That's why we started the day off with the area model. I could go ahead and make an area model here and go 2 times x, 2 times 4. And I can chunk it up that way if that is something you choose to do today. Okay, let's give it a go. We're going in full algebra mode now. So taking away those algebra tiles, let's go for this. I'm going to first acknowledge my multiplier here and multiply each term inside these parentheses. I have to give to each term, okay? So this would be 5 times x and 5 times 4. Simplified to 5x plus 20. It's that easy, okay? In example number 2, be careful with those negatives, kiddos. Negative 3 times k, negative 3 times positive 7. Okay, when in doubt, expand it out. Really write it out. Try not to do these in your head today. Weird things will happen. Okay, as I simplify it, I get negative 3k and negative 21. And again, I could have chosen to write the positive symbol here, plus minus. I got a little lazy, okay? So either of those are a correct representation. Okay, in the last example, I think in this first section, negative 9 times 3m, negative 9 times negative 4. Careful with your signs, just like we talked about yesterday. So here we would have the final product is negative 27m plus positive 36. Okay, careful with that double negative there. Or what I was trying to communicate to you guys yesterday, you could say the word opposite. The opposite of this positive is a negative. The opposite of this negative is a positive. Okay, pause the video. Try it. You'll do fine. What is the product of 6 times the quantity of y minus 2? I'm not telling you the answer. This would be the time to go in and check in with your partner. Did you share? Cool. All right. Last one. You try it. Check in with your partner when you're done. Did you guys get the same thing? Okay. And last section here. It's about to get real. Okay, so now sometimes the expressions are not so pretty. What we just did is more of a 7th grade standard. Let's go ahead and dabble with some 9th grade math, okay? So usually our expressions are going to be lengthier. So now we're going to use distributing and a little bit of associative property here, okay? And commutative too. Ooh, this got bigger. Okay, so now we have a longer expression. So when we go to multiply or distribute, notice how we're only going to distribute the number outside of the parentheses or the term outside of the parentheses. This 8x, we're doing nothing with it right now, okay? He's just there for the ride. Okay, so I'm multiplying in. This expression is really 8x minus 12 plus 36. So based on the previous examples I showed you. Now we have a second step of combining like terms here, okay? I have like terms, and so what I like to use are symbols or colors to represent things that are alike. 8x is a term with a variable. He's kind of a loner right now. It's okay. We love you, 8x. The negative 12 and the 36, they're constants, so we can bring them together. And so I'm going to go ahead and add those two terms together to get positive 24. Together, my final simplified expression is 8x plus 24. I can't simplify it anymore, so I walk away. Again, not solving anything. Okay, so again, in the second half, we are really slowing it down. We're distributing. We're using the associative property to associate common or like terms, and you could actually physically move them on your paper using the commutative property and then adding them together. And here we go. Again, step one, I'm going to go ahead and distribute that -2. Be careful with that sign. Carry the sign throughout. So I have 12 and 10W and -8. Again, acknowledging any like terms I have. I see my constants here in blue, my variable term in pink. 12 minus 8 is 4. And notice how over here to the left, although my expression started with a constant, in upper level math and algebra, we really want to start with our term with the variable first and then follow it with a constant. You're not wrong if you said the answer is 4 plus 10W, but you just won't match any textbook out there. Okay, they always start with the variable first and then the constants at the end. Last example. Oh, these are not looking very cute. Okay, going ahead and distributing in that negative symbol. This is a fancy way of saying -1. Okay, so what's the opposite of 7x? What's the opposite of -2? Those other three terms are doing nothing right now. Acknowledge your like terms. Bring them together. So I have 1x minus 7x minus another 7x, -12 and 2. Bring it together for a total of -13x and -10. Okay? So rather than giving you another your turn, let's go ahead and transition over to our pixel art. The cool thing about pixel art is if you do something wrong, you'll know. If it's supposed to be a picture of a unicorn, it will come out to looking like a blob. So just make sure you take your time. If it's not turning into a picture that you think it should be, check in with your partner, okay? I hope you guys have a great day. If you have any trouble with this topic, please do reach out. I have some Khan Academy videos that could also support you. Okay, so welcome to Algebra, you guys. Have a great day. Take care. Be good humans. Make good choices. And be nice to the sub. Bye bye.